Welcome back, engineers. In this video, let's look at cloud fundamentals. I think it's really important for somebody who is learning system design or doing system design or system architectures to really understand some of the basic terminology of cloud computing and the basic nomenclature and terms used in the industry which are related to cloud computing, right? So in this video, let's try to go through quickly the list of services that are available, the terminology that is used, and get some higher level understanding about cloud computing. I hope you're ready. Let's get started. So we'll start with a basic question. What is the cloud, right? So to understand cloud, we need to understand the difference between renting versus owning a data center. So if you are having a server, let's say this is a server box, let's say, and I'm the only one managing it, and if I want to give some piece of it to somebody else, then I would have to rent out that particular piece, right? So that is the basic difference between owning and renting a data center. So if I'm Google Cloud, I'm renting many servers to different customers and I'm charging against them. The formal definition is on-demand IT resources over the internet with pay-as-you-go pricing, right? So if you break down this terminology, it is on-demand, which means I'm not obligated to use it forever. I can choose when to use and when not to use. And they are IT resources, which means it involves IT stuff, servers, gateways, load balancers, and things like that, storage, and it is accessed over the internet. That is why it is called the cloud, right? So it is on somebody else's computer basically, and it can be accessed only via the internet and with pay-as-you-go pricing. So depending on what you choose in the cloud, you pay as you go along. And these are the big three players: AWS, GCP, and Azure from Microsoft. So these are the big three main cloud providers, and there are many more who are doing fantastic job in terms of providing resources, but by far these are the more popular ones, right? And here are some key benefits when using cloud. By using cloud, we are changing the expense narrative from capital expense to operational expense, right? So if I were to invest in a cloud server or a data center myself and maintain it, I would have to purchase it, I would have to keep it somewhere, I would have to do some air conditioning around it, the wires, cables, everything. Those are all capital expense. But when I choose a cloud provider, I leave everything to the cloud provider and I'm only dealing with operational expenses, right? That is a big advantage. And then we have agility, right? Because I'm not worried about building my own servers and maintaining them. I'm just cherry picking whatever I need from the servers, and because of this, my development speed and my business speed is actually improved. And then we have scalability. So I can choose when to scale and when not to scale, and whenever I want to scale, the resources are already available. I just need to tick some box or increase some number, and then I will have the scale that I need, right? So these are some of the main benefits of using a cloud. Next, I want to talk to you about three different models that are widely used in the industry. These are the acronyms IaaS, which stands for Infrastructure as a Service. So we can take cloud services in different ways. The first way is infrastructure as a cloud. In this infrastructure as a service, we are taking raw servers. We are just taking empty boxes like EC2 instances, let's say, right? And in that box, I can do whatever I want to do. I can build one application, I can build 100 applications, and the cost I'm paying is only for that empty box. I am responsible for everything that is going on inside the box, right? As you can see here, for infrastructure as a service, I manage the OS, the middleware, and the entire application, right? And the cloud manages only the physical server, storage, and networking. So they're not going to be bothered about our application. So for example, EC2 instance. The second way to use cloud services is platform as a service. For example, I'm trying to use something called GKE. GKE is Google Kubernetes Engine, right? So we discussed in the last video that Kubernetes is an open source project, anybody can use it. And Google itself is using Kubernetes inside the Google Cloud Platform and releasing it as a service, so that maintaining Kubernetes becomes simpler as end users, right? So if we want to take the entire Kubernetes system as a platform, then we can go for platform as a service. So in this, we are just managing the application code, the scaling and runtime, operating system and servers, everything is taken care by the cloud. So in this case, the platform is Google Kubernetes Engine, right? And another way to do it is software as a service. Let's say this is a finished product and I just want to use it as a user. So for example, Razorpay, it is a finished product and anybody who is using it is actually only responsible for the data and who has access, and cloud manages everything else. right? So this is software as a service, anything that you pay for directly using the software as it is, right? You're not exactly maintaining anything there, right? So these are the three main models or three main terminology that we need to understand when talking about costs or when talking about models within cloud architecture, right? Now let's look at some of the fundamental cloud services. You may be familiar with some of these, and these are the very famous ones. For example, when you need a compute, you want to process something, you want to run a server, then you're going to go for some kind of a compute. And there are multiple ways in which we can do that. First example is virtual machines. Like we discussed before, IaaS, infrastructure as a service, we are taking the raw servers, EC2 and virtual machines, right? And inside that we can do whatever we want. So this is one way of taking a compute. And another way is managed Kubernetes. This is platform as a service. So Amazon EKS, Google GKE, Azure AKS, these are all examples of managed Kubernetes. So they take care of managing the Kubernetes servers, scaling up, scaling down, and so on. And the third way is function as a service. So we are building serverless functions here, and the examples are AWS Lambda and Google Cloud Functions. So these functions are hosted on the cloud, and we are only paying when the function is invoked. Unlike the other cases, we are paying for the server as long as the server is up and running. In the case of serverless functions, we are paying only when the function is invoked, when the function is woken up and actually processed, right? So these are three different ways of using a compute. And then we can also rent storage. This is where we keep our data, right? So there can be two ways. One is object storage, which is the direct storage, which is not linked to anything. We can put anything in it and access through any application by using things like Amazon S3 or Azure Blob storage, right? So we can put files here, images, backups, and whatever we want to, right? This is not linked to anything. And then we have block storage. These are the physical hard drive for the virtual machines. So if I'm taking an EC2 server, I might need some storage, right? So I need to attach that storage. For that, I can check block storage for this, right? And then we can go for databases. We can go for relational or NoSQL databases. So these are the options that are available: RDS, SQL, DynamoDB, Cosmos DB, and so on. There are others as well, right? And then we can go for networking services. This is how services connect to each other. We can go for load balancers, we can go for gateways, we can go for securities nets, we can go for virtual private cloud and whatever. And all these topics come under networking. And then if you want to go for monitoring, we have services like AWS CloudWatch, Azure Monitor, Cloud Monitoring. So these give out ways to push logs into the system, and then they give out ways to actually run analytics on them, do filtering on them, and then keep a track of whatever is happening on our servers and so on, right? So these are only some of the basic fundamental cloud services that we might need when launching any application. And there can be others as well. We can go for authentication services like AWS Cognito and so on. We can go for data lake services if you want to run some analytics. We can go for machine learning like Vertex AI, AWS SageMaker, and so on. We can also do code level stuff, like we can have CI/CD pipelines running there. We can actually do code repositories as well on the cloud, and there can be many more such services, right? It's important to understand that these are services, and the names of the services can change from cloud to cloud, but the fundamental nature of the service would not change much, right? So these are some of the fundamental cloud services. Now let's look at some of the topics that are very specific to cloud computing, right? First in the list is virtual private cloud. So this is your isolated section of the cloud. Because cloud computing is computing happening on somebody else's infrastructure, we are not going to be responsible for the entire infrastructure. And we want our data to be isolated from everybody else, even though they are in the same physical data center, let's say. So how do I do that? I can go for a virtual private cloud. And within this virtual private cloud, I can control so many things. What data comes in, what data goes out, what are the security rules, what are the subnets. I can have cloud with virtual cloud within virtual cloud. I can have security groups which configure the ingress and outgress rules. And I can have route tables which talk about the navigation between the IPs within the virtual private cloud and so on, right? So this is a concept that is specific to cloud computing. And then we have regions and availability zones. So these are talking about the latency and fault tolerance, right? So I can actually choose which data center I want to put my server in. So if I'm in India, I might choose Mumbai as my closest region. If I'm in Japan, I might choose Tokyo, and so on, right? So the closest the server is to the users, the lower will be the latency, obviously. And cloud providers also give availability zones. Depending on how much you pay, the backups are taken in such a way that we get fault tolerance. So at least take some backup so that you don't have to be in a situation where your entire data is lost, right? So these are also some features that come with cloud providers. And finally, the important piece, the shared responsibility model. The provider is responsible for security of the cloud, while you are responsible for security in the cloud, right? This is very important to understand that whenever we are taking anything, when we are renting any service from the cloud provider is not responsible for the security of our application, we are responsible for it. But the security of the cloud itself is responsibility of the provider, right? Very subtle difference, but very important to understand. So how do I control my stuff inside the cloud? I can make use of services like IAM, which talk about identity access management, and security groups, which allow only certain IP addresses to talk to my virtual private cloud, and so on. So this is again one of the important concepts when we are talking about cloud computing. Now finally, I want to show you a sample architecture about a simple e-commerce application that I found online. And obviously this is not the only version, there can be multiple versions of this architecture, but I felt like it is a good example, and we can see how actually architecture diagrams are built and discussed within teams, right? So mainly this is talking about an AWS infra side, but we can actually go through the architecture and understand what is happening and how the system has been designed, right? So this is for an e-commerce application, and here we can see there is a client, and client is talking via HTTPS to different services, right? One of the services, Amazon Cognito here, which is for using authentication. And then client is talking to Amazon API gateway using API calls through HTTPS. And what is this API gateway doing? API gateway is talking to some kind of a Lambda, and Lambda is triggering some kind of events. So this is an event bridge within AWS, which takes care of pushing notifications or triggering some other Lambda functions within it, and so on, right? So these are all the individual Lambda functions that can be invoked as required, right? And on the other side, we have Amazon CloudFront, which is the CDN. CDN stands for Content Delivery Network, and it is useful for fetching static assets from a nearby location, right? And what else is there? We can see that there is a VPC here. This is the virtual private cloud I was talking about. And then we have the customer Lambda function along with a NAT, which is network address translator, which is mainly taking care of exposing one public IP address out of multiple. And then we have databases here, one RDS DB instance, and then we have one NoSQL database down here. And then we have FTP service, we have a products bucket, this is an S3 bucket, and then we have some more events happening here, followed by some external systems. This is for external loyalty. And then we also have email services, which is sending out an email to the user. And then we have a fulfillment Lambda function, which is listening on fulfillment notification topic. Whenever there is some fulfillment to be done, it is sending out a shipping order inside a queue to the warehouse, right? So a lot of stuff happening here, but just by looking at the diagram, we can see how that system has been designed, who is talking to what, and it also kind of makes sense if you look at it from a high level perspective, right? Basically, there is a user who is communicating through APIs, making an order, and the order is going through different events, and finally the warehouse is able to ship the order to the user, right? So this is how a typical architecture looks like. This is mainly heavy on the AWS side. All the icons that are used are from AWS per se, but we will learn as we go along in this series how to draw cloud agnostic designs, and we'll just talk about services in general and not specific to any particular cloud, although we just need to have an idea about what each service is referred to in individual clouds, right? Great, that's all I wanted to talk to you about cloud fundamentals, guys. This is probably the last topic in the core concepts. We'll move on to the different sections. Next, we will talk about numbers in system design. So stay tuned for that. Please leave a like if you found this helpful. Do subscribe if you haven't done already so that you don't miss out. Thank you so much for watching. I will see you in the next one. Cheers.